Hey mathematicians, here are things you need to know about exponentials and logarithms. First, you cannot take the log of a negative number or zero. Not possible at all. Next, the log of 1, regardless of what the base is, the log of 1 will always be equal to 0. Lastly, the bulk of today's entire video, solving exponential equations. You want to look at that diagram there to figure out what way you need to approach the problem. So first question you want to ask yourself with each of these problems today is, can the problem be rewritten with the same base? If your answer is yes, then you are going to change the bases, then solve from the exponents. If the answer to that question is no, then you are going to isolate the number that's being raised to the exponent and then solve by rewriting as a log. All right, here we go. We're going to go through questions 15, 14, and 13 from your homework, last week's homework. All right, let's start with question 15. Remember, this diagram in the top right corner is going to be super helpful. First, we need to look at the bases and determine, can the problem be rewritten with the same base? Our bases are 3, 9, 81, and 1/3. Those can all be rewritten with the same base. They're all powers of 3. So I'm going to rewrite each of those highlighted pieces as 3 raised to something. Here we go. I'm changing 9 to 3 squared. 81 becomes 3 to the 4th power. And 1/3 becomes 3 to the negative 1st power. All right, now from here, we need to start simplifying as much as we possibly can so that we can solve from the exponents. And anytime you see parentheses, you want to multiply the exponents. That's what the exponent rule tells us to do. From here, you want to start with the craziest looking part first. And in my opinion, the craziest part is the numerator. So let's condense that. We're multiplying like bases, so we need to add the exponents. From here, now the craziest part is just the left side in general. So let's go ahead and simplify that bad boy. Anytime you divide like bases, you have to subtract the exponents. And now that it's completely simplified on the left and the right side, we can just solve from the exponents. And our final answer is -1. All right, y'all, we're going to try another one. I want you guys to pause the video and think about, look at the bases. Think about, how am I going to approach this problem? Pause it now. Okay, so this is a problem where we can change the bases and rewrite those bases as the same number. So I'm going to change my bases and rewrite them as 5 raised to something, which just makes the right side 5 squared raised to that exponent. From there, just like with the previous problem, there are parentheses here. So anytime we see parentheses, we need to multiply the exponents. And now this one's pretty straightforward. Everything's simplified on both sides from this point, so we just solve from the exponents. This is a quadratic, so I need to set it equal to 0 to solve, and I can factor to solve this quadratic, so I'm just factoring this bad boy now. And we're going to get 2 solutions at the end because that's how quadratics work. One of our solutions will be -2/3, and the other solution will be +1/2. And that's it. All right, y'all, we've got one more problem to go. I believe this is question 13. Pause the video right now and think about, how are you going to approach this problem? Will you need to change the bases and solve from the exponents, or will you need to isolate what's being raised to the exponent, then solve by rewriting as a log? Pause it now. All right, guys, so hopefully your answer was, I need to isolate the number that's being raised to the exponent and then solve by rewriting, right? Okay, so let's start solving this bad boy. You guys know I don't like fractions, so for my first step, I am going to multiply both sides by the denominator, and that's what's going to get rid of this whole fraction scenario we've got going on. All right, so I'm just multiplying each side by the entire denominator, not just a piece of it. From here, I need to divide both sides by 2,000 because our ultimate goal is to get that highlighted part all by itself. When we divide both sides by 2,000, that's going to give us 5 on the left side. Next, to continue solving for that yellow piece, I need to subtract 1 from both sides. That's going to give me 4 on the left side. Struggling getting my pen out right here. Here we go. 4 on the left side. And then for my final step to get that part all by itself, the yellow shaded part, I need to divide both sides by 19. And this is our final step before we rewrite the problem as a log. Now, instead of me trying to figure out what 4 divided by 19 is, I'm just going to write here 4 over 19 on the left side. All right, so now we have it where we need it to be, and we just rewrite as a log now. Now, I told you guys about this E last time I saw you. Anytime you see that E, instead of writing log, you're going to write ln for natural log because the base of natural log is E. All right, so we've rewritten it. Remember, logs are always equal to their exponent. And then to finish solving this bad boy, we just need to multiply both sides by -5, which will make this -5 times natural log of 4 over 19. And I'm just showing you the 2 ways you can write this answer. You could write it with the E in there for the base, or you could leave the E out